In this video, we're going to look at how to name and recognize a different type of polyatomic ion, such as the ones that we see here. If we look at the one on top, we see that it has metal cations, just like the ones from the previous video. We see two examples of Na+, and we remember that the chemical name for the symbol Na is sodium. Now, if we look at the rest of this, we see that there is one carbon and 3 oxygens, and if we look here, we can see not one, but 2 negative charges. So what exactly is this large, complicated structure here? This is an example of what we call a polyatomic ion. Poly meaning more than one, atomic meaning atom, so polyatomic means more than one type of atom, and an ion indicates that it has charge. So the name polyatomic ion actually tells us exactly what this sort of compound is. And basically what a polyatomic ion is that it's a group of atoms that only exist together. So CO3 exists as one unit, and basically they behave in the same way that a single atom does. So in this case, CO3 2- is an anion, so the -2 charge will want to be balanced by 2 sodium atoms because each sodium atom has a +1 charge. Hence we have 2 of these compared to 1 of this polyatomic ion here. So again, you can think of a polyatomic ion as just multiple atoms that behave the way that a single ion does. Now, what about how to name this? Well, it begins the same way that naming a regular metal and non-metal ionic compound does. We start by naming the metal. We don't even need to look up Na anymore because we remember that its name is sodium from the previous video, so naming the first half of it is done exactly the same way. We need to look up the name of the polyatomic ion, however, and usually on a periodic table it will have a separate list of common polyatomic ions that are used in ionic compounds, and we can see right here labeled already is the name of CO3 2-, which is what we call carbonate. Now, unlike with standard metal, non-metal ionic compounds, we don't actually need to do anything to this name. The name of the polyatomic ion just becomes the second half of the name of this compound. So this structure, Na2CO3, is what we call sodium carbonate. Now, there's a variation on this where the ionic compound is actually 2 different polyatomic ions, and we don't have a metal within the structure at all. So in this case, if you figured that all that we need to do is write the names of the 2 polyatomic ions and then we're done, you're actually perfectly correct. And this is the easiest type of structure to name using these conventions. So all that we need to do is go to our periodic table and look up the names of NH4+, which is our first polyatomic ion, and NO3-, which is the second one. So if we look for NH4+, we see that it's right at the beginning here. This is a polyatomic ion that we call ammonium. And then if we look for NO3-, we see that it is called nitrate. So now that we have the names of both our polyatomic cation, ammonium, and our polyatomic anion, nitrate, all we need to do is put those names together, and we can see that the name of our compound would be ammonium nitrate. Just the 2 polyatomic ions, one after the other, and remember that the cation is always written first, and the anion is always written second. Now, if we take a look below, we can see that polyatomic ions get a little bit complicated. If we look here, all 3 of these are examples of sodium joined with very similar looking polyatomic ions. We can see here that the base polyatomic ion is PO4, and because there are 3 sodium ions, remember sodium has a charge of +1, and +1 times 3 is +3, which means to balance this charge, PO4 would need a charge of -3. Now, we can see that PO4 appears in every one of these polyatomic ions. However, 2 other versions of it also contain hydrogen, and all 3 of these are actually different compounds with slightly different names. Now, if we wanted to name the simplest one, we could start by naming the one with no hydrogens, because that will help us name the other 2. So we know that Na is the symbol for sodium, so that's going to be the beginning here. And then all that we need to do is look up the name for PO4. So if we try finding PO4 here, we find that PO4 3- has the name phosphate, which means that we would call the first compound sodium phosphate. Now, how to deal with the others that have extra hydrogen atoms here? Well, we can incorporate that into the name. So in this first one, because there is a hydrogen here, we can simply say that this is sodium hydrogen phosphate. Now, the problem about this naming convention is that this third compound here that has 2 hydrogens is also sodium hydrogen phosphate, which means we need a way to differentiate between whether it has 1 hydrogen and whether it has 2. Now, if we remember the numerical prefixes that are often used in science, we remember that the numerical prefix for 1 is mono, and the numerical prefix for 2 is di. You don't normally need to use the numerical prefix for 3 in this situation, but it is helpful to remember tri. Numerical prefixes will come back later for a different type of compound. So if we want to name this one here that has 1 hydrogen to differentiate the fact that it has 1 from this one that has 2, we can add the prefix mono next to hydrogen, saying that the cation is sodium, the polyatomic ion is phosphate, but that phosphate has 1 extra hydrogen in its structure. And then with the third one here, again, our cation is sodium, our polyatomic anion is phosphate, and there is a hydrogen within the structure, but instead of only having 1, we have 2. So in this case, we would add the prefix di here, so that the rather complicated sounding name is sodium dihydrogen phosphate. Now that you've seen how to name polyatomic ion containing ionic compounds, you can take a look at the practice problems below and see if you can name these compounds here, and you'll notice that some of them can be quite tricky because they have extra hydrogens hiding in their structures here.